We're, we're continuing on with these exercises for reference angles, and we're going to move on to number 3 and 4 here. Number 3. And you know, the first two are were kind of artificial. We're kind of strange because I don't think we're ever going to be in a situation where we start with a reference angle and we want to find an angle having that reference angle. The situation we're going to end up being in from now on is we're going to start with some angle and we're going to want to determine the reference angle for that angle, because the reference angle is going to tell us something about what's going on with the trig functions for that angle. So I'd say exercise 3 is the beginning of the real thing, sort of. So exercise 3, sketch 210 degrees in standard position and find the reference angle for 210 degrees. Okay, so let's see. 210 degrees in standard position. Now, degrees I think we like, right? We know it's more than 180. We know it's less than 270. It's a little bit more than 180. You don't have to draw it absolutely perfectly, but what you want to see is in standard position, 210 degrees has that terminal side in quadrant 3, right? That's going to be crucial for us to be aware of the quadrant that we end up in. Now the reference angle. Where is the reference angle for 210 degrees? The reference angle always shares the terminal side of the angle we have, and yet its other side is always going to be on the x-axis, positive or negative. It's going to be, we're always going to use the piece of the x-axis that gives us an acute angle, less than 90 degrees. So here we use the negative x-axis. The reference angle is right there, and that's the angle we want to find. And now notice here we're working from 210 back to the reference angle. What we got to do is we're going to take 210 minus 180, right? And I think that's 30 degrees. So the reference angle is 30 degrees. And we're not using this yet. What we're going to end up doing is see things we know about 30 degrees are going to tell us things about 210 degrees. So we're not going to have to memorize like new information about 210 degrees. All right, let's just, again, that's all we're doing there. Just finding the reference angle. And in exercise 4, we're going to do one with radians. Here we have 21 pi over 8 radians in standard position. Find the reference angle for 21 pi over 8. Now this is sort of an ugly one, right? Like 21 pi over 8. That's not one of the special angles. It's not a multiple of pi over 4, or pi over 3, or pi over 6. What's this pi over 8? Now let's just see if we can figure out what's going on here. And this is like a denominator we haven't seen before, is the way I would think of it. So I don't have a prefab picture to show you. But to get a handle on some of these fractions that we deal with when we deal with radians, let's just realize that if I wrote 8 pi over 8, so I'm using that denominator, but I'm writing 8 pi over 8. So that's equal to pi radians, right? And so I can work from this 8 pi over 8 idea. I know 8 pi over 8 would give me 180 degrees, or pi radians. If I double that, if I get 16 pi over 8, that's equal to 2 pi radians. That's full circle. And if I divided 8 in half, if I did 4 pi over 8, that's the same as pi over 2, or that's like just 90 degrees, right? So even though I'm not familiar with pi over 8 so much, I haven't thought about it that much, I can use some of these easier to think about values to help me picture where 21 pi over 8 is. In fact, I'm going to count by 4 pi over 8 as I go through each quadrant. So I'm going to kind of say 4 pi over 8, 8 pi over 8, 12 pi over 8, 16 pi over 8, 17, 18, 19, 20 pi over 8. 21 pi over 8 is going to be a little bit more than full circle, 90 degrees more, and a little bit more than that. I don't have to draw it perfectly. I just want to make sure I get my quadrant right here. There's 21 pi over 8. So do you see, again, how I kind of counted by 4 pi over 8. 20 pi over 8, 20 pi over 8 would have stopped right at the positive y-axis here. Because it would have been full circle plus 90 degrees more, right? 16 plus 4 is 20. So I got 21 pi over 8. And the reference angle is right here. And what we want to figure out is, well, what is that, right? Now, what you don't want to say is, a common mistake is to say the reference angle is pi over 8. Pi over 8 is the angle right here, but that is not the reference angle, because the reference angle always has to touch the x-axis. So this is a real common mistake people say. I know we went pi over 8 beyond the positive y-axis, but the reference angle never touches the y-axis. It always touches the x-axis. So we have to actually think, like, if I kept going all the way to the x-axis, that would take me to 24 pi over 8, right? So again, counting by 4s, I'd go from 20 to 24. And so to get this reference angle, it's kind of like I want to take 24 pi over 8 minus 21 pi over 8. And I get 3 pi over 8. Now some of you will be able to figure this out without even subtracting, right? You'll just be able to say, how much more do I need to get to 24 pi over 8? So 3 pi over 8 is the reference angle. So this is a tricky one. But the picture helped me a lot. And there we go. And I think we're going to do the last two exercises in a separate video. We'll cut it off here.